Everyone, welcome back for another tutorial. And in this tutorial we're going to keep on working on a foldable. Last time we did 9-3, that's similar right triangles. Now the next page, which should be the third page now, go ahead and fold it so that we form a right triangle again if you haven't done so already. So there's another right triangle, and on this one what we're going to write down is the following. So this is 9-4, and this is for special right triangles, okay? So this is a special right triangle. This angle is 45, this one is 45, and this is a right angle. And the pattern is X, 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 radical 2. Okay, and this is the pattern you're going to learn about through this tutorial. So 45, 45, 90, this is a leg, and that's X, another leg, and that's also X. And this one here is the hypotenuse, the side across the right angle, and this is X radical 2. So that's the pattern that we're going to work on. Okay, so I'm going to flip my paper open, and I'm going to advise you to do the same. Okay, so here I'm going to give you a few examples. And again, we're going to write up on top special right triangles. Okay, so I want you to please follow me along. So let's say here we have special right triangles, okay, and this so this here is 45, 45, 90 degree special right triangles. So I'm going to just point something out real quick. So when we deal with special right triangles, especially 45, 45, 90, start with a square, okay? So don't forget, in squares all sides are equal. So this side is X, this one is X, X, and X. So each one of them is of side length X. Now, once we introduce the diagonal, don't forget these are all right angles, okay? And once we introduce the diagonal bisects the angles, so that means it cuts the angles in half. So now we have this is 45, this is 45, and that's a right angle. So I'm going to take this, I'm going to pull this one out, and we're going to have the following right triangle. Okay, so this is the right triangle, that's this triangle here. So this is 45, and this is 45, and that's a 90 degree angle. So now we can write the pattern. So this is X, X, X radical 2. And then our table, so that's 45, 45, 90, and X, that's a leg, and this is X radical 2. So we have an isosceles right triangle. So this is the table or the pattern that we're going to use to solve problems in class. Okay, so I'm going to give you one example next. So this is example 1. Okay, so in this example, let's say we're just asked to fill in the missing measures. Okay, so we have this right triangle here, special right triangle, and it's 45, 45, 90. And let's say we're just given that, we're given the legs, it's an isosceles right triangle, and we need to find the hypotenuse. So we start with our table. We know it's a 45, 45, 90, and we know across from the 45 degree angle That's this leg. So that's giving us, okay, that's x, x, and this is x radical 2. And then x is, as you can see, is 3. So this is 3, and this is 3. Okay? Now, as you can see, x is 3, so that means this is 3 radical 2. So then we can get the hypotenuse just by following the pattern on the table. So x radical 2 is the length of the hypotenuse. Now, real quick, I'm going to give you another example. Okay? And let's say now we have this other right triangle. And again, it's a 45, 45, 90. And in this case, let's say we're given the hypotenuse. And so the way we do it again is we start with our table. So 45, 45, 90 degree special right triangles. We know this is x, x, and this is x radical 2. Now this is the only thing that is given. We're given the hypotenuse, and that's radical 10. Okay, so we got to solve for x. In this case, I'm going to do it algebraically, but then I'm going to teach you a shortcut. And I'm going to go in class over a couple of examples for this here so that it kind of start making sense for you. So we know x radical 2 equals 10. Remember, we solve for x, we just divide by radical 2 on both sides. So divide by radical 2. And then we find x equals, and then divide 10 by the number inside the radical. So that should be 10 divided by 2. That's 5. And then keep the radical next to the 5. So this is 5, and just keep the radical 2 in front of the number 5. So then this is now 5 radical 2 and 5 radical 2. So that goes here, 5 radical 2, 5 radical 2. So that was our example number 2. Okay? Now the last example that I'm going to give you is for simplifying radicals. So let's say we are asked to simplify the following radicals. So let's say we have the following radical. So we have a radical 8 times radical 5. That right there means we're multiplying the radicals. So what we do here is we just multiply the numbers inside the radical, which are called the radicands. You will see this in Algebra 2 again. So 8 times 5, that's 40. So that's radical 40. But we need to simplify the radical, okay? So this is example 3, and we're going to simplify the radical. Now, think of perfect squares. I know you've seen the tree, some of you, and some of you don't understand the tree. But you can also, if you kind of remember squares, think of the factors of 40, okay? So the factors of 40 that have a perfect square, that's what we're looking for. So for instance, we know that 4 times 10 gives us 40, so that's what we use. So then we do 4 times 10. That's the same as 40. So if we do this again, 4 times 10, that's 40. And then we just break them apart. And maybe that will help you make sense out of the problem. So radical 4 times radical 10, the square root of 10. But we know 4, the square root of 4 is 2. And this one, we just leave it as it is. And that's as simple as we can get. Okay? So that's simplified. Now I'm going to give you another example, and this one is a little bit more challenging. So this one is 6 radical 3 times 2 radical 8. So for this one here, we first multiply, as we did in class, numbers outside of the radical. So that's the coefficients, or 6 times 2. So we do 6 times 2. I hope you understand that's 12. And then we're going to multiply the radicands just like we did here, 8 times 5. Now we're going to do 3 times 8. So that should give us 24. Okay? And again, 24, let's think of the factors of 24. That will be a perfect square. So this is 12, that stays the same. And then let's break down a radical 24. Factors of 24, we have 2 times 12, 3 times 8, and 4 times 6. So 4 times 6, that's what we want, okay? Because as you can see on the previous one, we have 4 times 10, but we knew that 4, the square root of 4 is 2. So again, this is 12, and then, so I'm just going to skip the step because I hope you understand this is this one. So I'm taking out a 2, so this becomes 12 times 2, and then we keep the 6 inside the radical because that's not a perfect square. So 12 times 2, that's 24, and then that's 24 radical 6. And this is as simple as we can get with this radical. Okay? I'll see you in the classroom. Bye-bye.